Welcome back, everyone. Yesterday, we explored the basics of production and the transformation process. Today, we move into a critical tool used in production and engineering environments, process flow diagrams, PFDs. Before we start, here is a warm-up. Learners are to define production and IPO in their own words. A PFD is a visual representation of the steps in a process. It uses standard symbols to show how material and energy flow between equipment and operations. PFDs help operators, engineers, and management understand and optimize production. Now, time for a question. Why do we need PFDs instead of just written instructions? PFDs communicate process steps clearly, identify critical control points, help with safety planning, and are vital during troubleshooting and improvement projects. Now let's time to discuss or to share one situation where visualizing a process can prevent mistakes. Symbols make diagrams universal. Common ISO symbols include those for pumps, tanks, heat exchangers, conveyors, valves, and control systems. Everyone in the plant can read and interpret them the same way. Activity. Show symbol cards or slides and ask learners to identify what they might represent. We use standardized shapes and icons to represent equipment, direction of flow, and measurements. Lines indicate flow paths. Control points and monitoring equipment are marked clearly. A typical PFD is divided into sections. 1. Input feed. 2. Processing units. 3. Utility systems and output streams. Each section shows what equipment is present and what happens at each step. Activity. Ask learners to identify sections on a sample PFD on projector or printed afters. PFDs display equipment such as furnaces, mills, pumps, conveyors, tanks, etc. Symbols don't show exact detail, but enough to identify what is happening at that step in the process. And now it's time for another activity. Learners work in pairs to list common equipment used in their industry and where it fits in the process flow. Safety is built into PFDs. Emergency shutdown valves, monitoring points, pressure gauges, and alarms must be shown clearly. This ensures operators know where to isolate or control the process during an incident. Activity. Where would you place safety controls in a high-pressure line? Take time to discuss. Material streams are shown as lines, usually with arrows to indicate flow direction. Raw materials in process streams and finished products may have different line styles or labels. Control points are placed where monitoring is required. Activity. Ask learners to identify flow, direction, and control points on an example diagram. When one step in the process fails or changes, it can affect upstream and downstream equipment. Operators must understand these interconnections to manage disruptions and maintain quality and safety. Activity. If the pump fails, how will it affect upstream and downstream? Individually or in pairs, create a simple process flow diagram for a product, such as water bottling, bread baking, or a packaging line. Include at least input, process steps, outputs, symbols for equipment, flow arrows, and 3 safety control points. Activity. Your facilitator circulates to assist, ensuring correct use of symbols and clear flow direction. Collect drawings as formative evidence. Learners display their diagrams. Facilitator and peers provide constructive feedback, checking for correct symbol use, logical flow, and placement of control and safety points. Activity. Highlight common strengths and areas for improvement. EISA often includes questions like interpret this process flow diagram or draw a simple diagram showing process steps and control points. Be prepared to explain why each symbol and step is used. Reflection prompts. What is the purpose of a PFD? Which symbols were easiest or hardest to remember? Where would you place safety features in your process? How could a PFD help during an emergency or breakdown? Activity. Facilitator collects reflections or discusses with class. Thank you for your attention and participation.